everyone. As Bob said, my name is Wolfblack. I'm working at ATS with Peter Burkholder, and I'll only take you through the agenda of today's presentation, and we'll just hop into the meeting. That's me. Let's figure out how to click. There we go. Perfect. Very fine. So today we have roughly a four-part presentation. We'll start with introduction. Then we're going to talk about what we see as the state of cloud today, or rather the very cloudy state of cloud today. Then we'll talk about some of the best practices that we observe think might be useful from our own perspective, knowing that the exact situation at every agency can and will vary. So our words are not gospel, but they're a set of ideas that you can use. We'll then take you through two different products that ATS and CPS run, one called Cloud Backup, one called Federalist, and use each of them as case studies of how we apply our principles and hopefully showing the good results that you can have from applying those principles. So first, to start with introductions, I'll do myself and then Peter. My name is Will Black. I joined GSA and joined the government in March 2015. I joined that from a world where I was working with large hospitals doing large enterprise IT installations. I really think the world of healthcare is pretty similar to the world of government. I was surprised by there's a lot of different systems, a lot of different departments. Cardiologists know exactly what to do there. Gastroenterologists know exactly what to do there. There's not always a lot of communication, even though a lot of the needs are common. And I think the same thing applies to cloud. Program needs can really vary from an office to office, to an agency to an agency, but the underlying support structure can and will have common similarities. So I'm happy to be here to serve with Peter, and I point out on the right side of that slide are so many of our wonderful colleagues that you don't see. There's a wide diversity here, and we represent two of us.
Hi, and I'm Peter. I'm the other person on the slide. I have almost 2 years with the federal government with 18F. As mentioned in the earlier introduction, I was originally trained as a geophysicist, but as I was working through masses of data, I found that I took greater satisfaction in not just looking at seismograms, but in aiding people to use technology more effectively, and that's been a thread through my career. Immediately prior to working with 18F, I was with Chef Software working with enterprises that weren't that dissimilar from the federal government in highly regulated industries, trying to determine how to modernize, how to leverage what they were currently running, and then moving into the cloud and taking advantage of those technologies. So really glad to be here today and to be involved with you.
Cool. Now, Peter will take us and lead us through the cloud today.
So this is a very high-level overview, and I'm sure most of you are familiar with where the federal government is in cloud adoption. But I wanted to address what we see as some of the goals for cloud adoption and what some of the impediments are to getting there. As you may recall, back in 2010, under the last administration, it was clear that there was going to be a significant emphasis on cloud adoption, and Cloud First was announced as a strategy in February of 2011. Where we are today, 7 years down that road, is some lag in that adoption. The IT scorecard for the federal government showed that in fiscal year 2016, only $2.6 billion of $85 billion spent was on cloud services. Overall, something like 8% of that spend was in non-provision services, meaning services that were already ready to use. In the last IT report from the last administration in 2017, zero agencies have gotten to the point of actually running 15% of their workloads in the cloud. We do see real progress moving forward. The FedRAMP program, which authorizes cloud service providers, has hit the milestone of having 100 authorized providers in the marketplace. The modernization of revisiting the trusted internet connections to play better within a cloud-connected world is well in play.
Turned on.
It is turned on, but it's off my laptop.
Oh, that's not that way it's planned.
You can hear me, but I was far away. Now, that's better. Great. And we have this investment in centers of excellence with USDA as a lighthouse agency to really take on this opportunity. The first 3 years of the Cloud First initiative saw a lot of focus on cost savings. The focus pretty much since 2013 is talking more about the ability to modernize the way we do IT because it's not always immediately evident when those cost savings are going to be realized, but you definitely see a payoff in terms of having OpEx operating expenses of capital expenses. We're also missing opportunities in security by having, when we continue to maintain our own security from physical security to network security to operating system security versus large providers like Amazon, Google, and Azure and others to deploy global networks to observe developing threats, to absorb like a sponge, things like distributed denial of service attacks. And then there's the whole question of automation, moving to actually having APIs that drive your changes to infrastructure, using infrastructure code, which is much more feasible when you're using a cloud platform than when you're having to build from the ground up. But mostly, my interest in being at the federal government is to look at how we have mission-focused information technology, where we're taking a lean approach to developing products, getting it in front of customers, getting user feedback on that, and being able to use agile development techniques to continue to build in small batches and deliver from as early in the process as possible and actually see innovation. This is what we've been seeing happening across sectors in the last decade.
Also, one other note just about this, though. We know that these missed opportunities are not because civil servants are, like, missing the ball. In a lot of instances, it's people trying to fit modernization efforts within existing operating expenses that are already stretched to accommodate all the things that you have to do. Sometimes these are situational or systemic failures that are making it difficult to fit these other things in. One of the functions of 18F and the work that we do is kind of walking in, and we can be outside experts to kind of say, hey, you know, this isn't going to work, and help bolster the case of someone inside an agency that's trying to do the right thing, but doesn't have the setup necessary to do that. We are best when we partner with someone inside an agency that knows how that agency works. So likewise with cloud adoption, it is strongest when the parts of an agency that know cloud and know the technology are partnering with the program offices that can say what they need, because unless you have a partner that's inside the group that you're trying to change, a lot of times you're tossing things over a wall and not really communicating, and that can be difficult.
So, so in the last decade, talk about mission-focused IT, has been a realization in the private sector and increasingly now in the public sector that information technology does matter, despite the highly regarded and often referenced paper from 2003 by Nicholas Carr in the Harvard Business Review, that IT doesn't matter, because at that point, IT had been very much a undifferentiated commodity that people would buy their enterprise relationship management system or their email system or their HR system and put it in a closet, and it was seen as a cost center. And when you're doing the same, getting pretty much the same EMR across different industries, then it doesn't actually see any change in the bottom line. When you have a decade, so you saw a decade then of essentially underinvesting in innovative IT in the private and public sectors, I think to some degree from the influence of that paper. However, at the same time, we were getting the beginning of actual cloud technologies. We were seeing things like configuration management come out. The Agile Manifesto came out in 2001. We actually had processes for developing code fast. And there was you could not look at companies like Amazon and eBay and Etsy and not say that IT doesn't matter, because they were in the processes and the ways they were building technology, they were outperforming their competitors. In 2014, Gartner came up with this model, saying, well, it's bimodal IT. You have systems of engagement and you have systems of record. And systems of engagement, like websites, could potentially run at this much higher velocity. But the systems of record, well, we still have to manage them with ITSM, change management boards, a high number of gates and processes in order to assure stability. But it's been shown that you actually can have speed and stability, particularly in the last decade with the surveys across the industry that have been summarized in the State of DevOps invested in IT, we see striking results. When you survey tens of thousands of people across the industry about how they develop and deploy software, they pretty much separate into high-performing teams, performing teams, and low-performing teams. Astonishingly, the high-performing teams will deploy so much more frequently that the numbers kind of boggle the mind. 200 times more than low-performing IT. And you can go from conception to code to production in much shorter lead time. As a result of the automation and testing goes behind that, you have lower change fail rates, faster recovery from failures, less time spent remediating security issues, and a culture that actually injects learning back into the system. The people who work at these organizations are 2 times more likely to recommend where they work as a place to work. Is there anything to add to that?
I think that from talking to people all across, like the vast majority of CFO agencies, a slide like this can oftentimes appear like wishful thinking because there are so many more constraints that the government may bring. We also see that sometimes the things that make this feel impossible are based on how people have always done things and less so on how you're actually required to do things. So our goal with this presentation is to help show you ways of getting to this place or closer to this place within the whatever constraints of your agency, while knowing that, all the full benefits of automation are sometimes limited by, forces that you don't control, either within an agency or across the government as a whole. But the benefit of going in this direction is still present. Yeah, even if you are here, going in this direction is helpful. If you're here, going in this direction is helpful. We're trying to give you an orientation more than an exact set of things that you need to do so that you get closer to this slide, even if heading it exactly is not a thing that's going to happen in the next 5 years, but could be in the next 10.
And we'll see real examples as we move on.
Yes, we will.
Part of this is changing what we actually value as we evaluate the measures behind the work we're doing. Traditionally, people try to look at things like lines of code, and frankly, the best developers I've worked with have removed more lines of code in their careers than they have. Taking measures from agile like velocity, which are not supposed to be used as a comparison, and then trying to play different teams off of each other. Utilization doesn't really work either because once you get above a certain level of utilization, it means everyone's being used all the time and they can't take on new work. The work gets bogged down in the system. Operationally, there's been this traditional focus on mean time between failures. And instead, we want to change, to have on the right, a focus on mean time to recovery. How fast can you detect an incident and remediate it and then keep going forward? Likewise, focus on strict uptime is much less useful than having something like a service level objective, an SLO, which is based on actually observing the customers coming into your site and seeing are they meeting a certain level of response times for a certain percentile there. So the high performance measures is how frequently can you release? Is it once a year or once a week or once a day or multiple times a second in places like Amazon? Lead time, how can you go from committing a simple change like the color of a button to actually being able to see that running in production? And again, having a low failure rate for those changes and mean time to recovery. So that is the landscape of where we want to get to in terms of being able to go to having systems that give us these high performance measures of high release, low change fail rate, and high recovery if anything does go wrong. And now will kick us off with the strategy.
So I'm going to talk through about 10 or so, maybe 9 different areas of strategy. I want to be really clear that this is a new presentation, and the exact delineation of these 9 things is not a pure, I wouldn't make this as the 9 steps, and then you're in the cloud and everything is great. These are all different types of ideas. The way that you can organize these, because this is such a survey of a really big field about ways of operating, probably means that there are more academic ways to say, it's really this set and this set. I'm really more here to give the general broad set of ideas. Some of these things will have overlap. There'll be gray area in between them. So please don't consider how we break things down to be the most important piece as much as the ideas that we're presenting one by one by one. So with that, let's do first, start small, start core. What we mean by that is that before you plan out a big cloud implementation, and there's a real big tendency in the government to say, we're going to do something really huge. We're going to move all of our stuff into the cloud in the next 2 years. How much is that going to cost? Get that money in the budget and go off and do it. Don't do that. Start by saying, we're going to move one system, a core system, an important system, one that has real risk if it fails. You don't want to pick something that is kind of a free system if it doesn't work. It needs to be important, but it also needs to be small. And that way you can learn and adapt, and if there is some kind of issue, recovery from that issue doesn't involve, 200,000 lines of data being at risk or something like that, but something important that's not huge. So an example of that might be if you're, let's say, the Forest Service, and you're running a system that involves permitting for trees, and this is real, you might say, we're going to change the system of how we permit for one tree, the lowest rate of permits that we need to issue for that tree, so that there's a problem when we need to flip back. That's not a big manual lift for us to do. But that's a real system. It's subject to all the same statutory rules, all the same regulations within an agency about how they need to do something, and then you'll then take that example and as you go through it, broadcast to the rest of the agency and broadcast within your team and around your team how it's going and what you're learning. It's really important to find all the things that don't work, all the areas where you stub your toe. Even if you, as the project manager of this migration effort, are the one that notices it and then fixes it independently, it's still important to call that out because a lot of other people will be doing what you're doing, and unless you document what you run into, so that if they give an issue and they search for something in a wiki or in a internal reference database, if they can't find anything, everyone's going to come along and stub their toe again and again. And that adds up very quickly to become a lot of time lost, or even worse, someone might make the error that you caught, and then if that error is not caught and it's combined with some other issue or another issue, you could have an unexpected kind of chain reaction that causes something really serious. So the importance of broadcasting is to specifically try to find as many problems as you can, but on something small where that's okay, and then be able to, once you have that thing live, you'll have learned, I'm going to guess, about 70% of the stuff you need to know to migrate everything, just because so many of your rules and processes apply across the board. Now that 70% is not a hard rule. That depends on, the type of system and if it's, the relative complexity of what you're handling as an agency. But you'll discover much more than you think of the things that block everything by doing one thing if you do, instead of trying everything in one big, massive go. You're going to kind of choke yourself otherwise.
And this is something that I saw when I was working with private industry, is that they would take what we would call a boil the ocean approach, which, again, they don't know these new technologies. They're trying to learn on the fly, and at the same time, they're trying to wrap it up onto a 2 or 3 year plan. And you can't plan around what you don't yet know. So starting small is not just is key for actually learning. In every culture, the need of every institution is going to be slightly different. We can provide playbooks from which you can select ideas, but there isn't just one size fits all for migrating an institution to both cloud technologies and realizing benefits of modernization along the way.
So you'll know you're doing this well when you have one team that's managing this, and this team has all the skills it needs to accomplish the full mission. So that may mean detailing people over from your acquisition shop or from a DevOps shop or from your security organization into one team so that the team can problem solve as they track in daily meetings. You want them to have high availability to each other so that you're not having to wait for long response times, because there will be a lot of different blockers that come up from a lot of different areas. And it's really advantageous, even if your team doesn't have the CO necessarily on it, to be able to have someone that can act as the core. So that it has a good relationship with that CO so that you can get answers quickly, because there will be a lot of surprise blockers. One of the ones that you'll probably hit if you're doing any kind of cloud buy for the first time is that we don't really know as a government yet how to buy variable usage cloud. It's kind of like buying power. It's kind of like buying utility. You don't know how much power you're going to buy before you do it, but the section of the FAR that deals with power is totally different than the section that deals with IT. And in fact, you can't apply the section of the FAR for utilities onto the IT buy. So that's a really different thing that a contracting officer is going to have to get their head around. It takes, in my experience, a lot of conversations, sometimes multiple conversations, because you're not just asking someone to do something different. It's kind of like getting on a bicycle where turning right actually steers left. Like, it's a different thing. You can eventually program your brain to do that. There's people on YouTube that have done it. But it takes a long time to figure it out. And then if you do earn it, you can, win money at a carnival when someone says, you can't do this, and you can actually win the money.
So one thing about the team is that if you're told you can't dedicate a security person and an acquisition person, et cetera, to the team, the important thing that you know when you're doing it wrong is when you have to wait for tickets to be submitted and then answered. If you need something from acquisition, you should have Maria or Arun you go to, and they say, oh, I know this project, and I can make time for you this afternoon to work on it. And they actually are invested in the outcomes of that project. So it is essentially DevSecOps or ACT, DevSecOps, compliance, all strung together, but there is a sense of mission among project teams to actually deliver on this core project.
Let's unpack that word DevOps for a second. So DevOps is when you combine work from development and work from operations, and you're having them kind of work in the same field. We say DevSecOps because we want to include the fields of compliance and security with that. And then ACT DevSecOps is just really saying, let's get everyone in the same room so that you have people who are available to you. You will not be able to do this sometimes depending on the amount of executive cover that you have. It's really important, though, to get that executive cover. Sometimes I think agencies make big, massive plans, and they make big announcements, and because planning for something that's that big is really exciting, and it's easy to get executives and people on board behind a shared vision of, we're going to cloud in 3 years, and it's happening, and we're all really excited about it. But that's not going to get you to a place of success. Most of the time, you're going to end up kind of pedaling your bicycle kind of into a mud, and then you'll get stuck instead of doing something smaller, quicker, faster. So get that same executive backing, but to try out something, and that way when you make that 3-year plan, you'll be that much more informed.
We're spending a lot of time on this slide because it is the most important.
Yeah.
And if people say we can't get to the cloud in 3 years if we're just starting with Christmas tree permitting, and the answer to that is when that team spends 6, 12 months figuring out how to actually work in an agile fashion, to start planning on shorter iterations and delivering on that, then that team can start training other teams, and you'll actually see a then geometric or exponential growth in your ability to achieve this. And I think Disney has some great presentations on how they move to a DevOps culture by starting small in certain properties and then growing out from there. Unfortunately, they're not online because of IP. I shouldn't have brought them up as an example.
Well, but that's why we do what we do. Like everything that 18F has, all of our documentation, our handbook itself is all public at handbook.18f.gov. But pretty much anything you want to find about us, it's all online, it's all public, it's all either on GitHub or it's at guides.18f.gov, or there's other URLs that we'll go through in this presentation. Our goal is to give you examples that you can reference so that you can go back within your own agencies and be better equipped to make an argument to do the right thing. That's our mission, and if you have a question or an issue about that, we're always available at 18f@gsa.gov to help answer those questions, or our individual emails will come up at the end of the presentation. I think we're done with this slide for that now.
Let's move on.
Start small, start core. Next up, live prototyping. So when I say prototyping, I don't always mean prototyping in the open, but I'm going to talk about operating in the open for a second, because most of the systems that we run as a government that serve the public are in public. Your prototypes for these systems that serve the public and are visible to the public should also be public. Otherwise, the prototype isn't really a prototype. And you should be trying out all the stuff that you want to do to a system, all the new things you want to do it, all the new deployments you want to do it, in a staging or a test or somewhere before the production system, but that really acts like the production system. There's a tendency sometimes to say all the rules around production are so hard and so onerous, it's only really worth doing all that stuff for the production system. But then you're never going to catch the issues that affect production. I'm having an issue right now with a system that locally, it works. Run on the command line, it works. Deployed into the actual system, something is bugging at line 64 in a library, and no one really understands why. And it's taken us 2 days so far to trace the issue and figure out what's going on. You need to have a real prototype. You need to have a real deployment system that allows you to stop before you get to production and find the issues that are happening, because that's what makes these rapid releases and deployments safe. It just it's what allows them to work. We have huge change control boards and big change control meetings to control this risk because there's no other way to evaluate, or people don't feel like it's safe to deploy to everyone.
So by we, you mean that is the status quo. That's what we're trying to get away from.
Yeah, as the government right now. People, to make things feel safer, you bring other people into a conversation. But the safest thing to do is to make it really easy to make a change, but have a stop along the way, that prototype where you can make sure something is working. And then the other cool thing is once you figure out how to do that with one staging system, you can do it with multiple systems. You can do multiple versions of a system with different color schemes or different workflows to allow people to test out each one at the same time. You could do multiple versions of a system to help make the case of, hey, if we do it this way and spend a little bit more money making the whole system this way, we'll get that much better result. Showing people something real is so much more effective than showing them a screenshot or showing them a Word document. And it allows them to actually test it and mess with it.
And we'll get to this more when we get to the security side, but if you're wondering how do you get security on board with this, you start early. So by starting with a live prototype from week 1, if possible, it means you already have the stakeholders involved early on to say, yes, we can go ahead and approve this beta site and make sure your systems are following our policies. Then there's not a long wait for when you're actually needing to go live. It might just be as simple as getting someone to sign off on the ATO and change the URL.
Another blocker you might have when it comes to prototyping is the fact that people want to be able to announce something new when it goes live, and they worry if we deploy this early, we're going to remove our ability to announce it. It's going to mess up the kind of PR or the publicity of the thing. I am here to tell you, no one checks your prototypes from the outside. We have prototyped so many things that made a big splash when they launched. It's all public. It's all there. People can visit it. Not one news story has ever come out about a thing we launched before it launched, because watching someone else work is a job, and people all have other jobs to do.
I think opiates was
that's a good
one
example.
that just came out a few weeks ago.
Well, you mean the opioids backup website?
Opioids backup.
Yeah, that was one that was prototyped and then made available, but it was it's a rational concern for people to have. But don't worry about your thing leaking because it's public. Whatever might cause an early announcement is not going to be tied to the status of your software for the most part. Even if your code base is private, you should still have a publicly available prototype, because otherwise you really can't test your system that's meant to serve the public unless your prototype is also public. It needs to act exactly like your live system does, have all the same constraints if you really want to be able to learn from it. Cool. Anything else on the slide? Let's move on. Let's carry forward. Version control. Everything you do for a system should be represented in version control. Even the stuff you're not used to doing in version control should be represented in version control. Version control deployed effectively is something that we think should be done not just in the technical parts of an agency, but that can include your less technical folks. I have trained everyone that I've ever worked with in how to use GitHub as an example, although you can use Bitbucket, GitLab. There's a lot of different services out there that provide this. And while it's tricky to initially learn, it is teachable once people get over the fact that screens are so busy. They're not very usable, but it's really important to get version control out there and to express everything you're doing with your system in version control. You can start with that version control system being local. It can be on someone's even a local PC for that first deployment that you do. That's okay. But eventually you want it to get into the cloud or get into a SaaS-based solution because that'll be more powerful, and then you can take advantage of all the new features that are coming out with these services as they compete. We as the government get to benefit massively from the fact that these services are out there, and they are rapidly going at each other in terms of providing new services and features, but you only take advantage of those when you are using the outside services and features and being able to use them. You'll know that this is working well when peer review on your, or the first step of this is that peer review on all code changes should become normal. The idea of someone making a hot fix to prod, if you make your deployments easy enough, people should be able to just commit it straight through the version control system pretty easily. Yes.
Oh, I have so much to say on this one, where to start. But I'll just start with Jeffrey Snover, who's now the lead for Microsoft Server. In the mid-2000s, he took a step back from working on Microsoft UIs to write PowerShell. And then when they were able, and then he said, when he started working with teams that were able to move from making all the changes to a distributed system through user interfaces, to expressing that in code and committing it to version control, it was delightful to go around and talk to people because they'd say, oh, let me show you this subroutine that I wrote or this library that I'm sharing. And it made sharing and conversations around the work that they were doing possible in a way that just working with user interfaces and one-offs didn't provide. So the version control is not just about audit and control, but it is also about communicating about the changes that are happening, being able to test in small batches, because you don't want to give someone, here's the last 2 weeks worth of work, please review this for me. It means you have to be saying, how can I express what I'm changing in something that's like maybe 10 or 1 or 100 lines, so that other people can say, okay, I can see what this change is going to do, both in terms of the test that you're writing around it, but then also thinking through what are the other side effects that aren't immediately apparent.
As you have personnel changeover on your team, having centrally available version control helps you understand why a thing happened the way it did, especially when people are having communications over those pull requests, over those issues, using the tools of version control to really start collaborating and communicating. You'll also know this is working when people start looking at their commit history and thinking, you know, that's a source of pride for them of showing the cool work that they've done. And as you start moving all the things you do in operations to code changes. So for example, you can make updating your DNS using Terraform and some other technologies. You can make DNS represented in code. And that makes it so much easier to figure out what in the world happened, because DNS is hard enough on its own. Like, remove this part of the complexity and you end up at a perfect spot. Let's keep moving for the sake of time. Be agile. Okay. Agile is not as much there's a lot of different trainings and representations of what it means to be agile. We have been called sometimes by people that have been told, my FDS told me I need to do an agile something, but they don't actually know what agile is. And it becomes less safe to even talk about it because people don't feel clear about the definition of agile. That's because agile doesn't have necessarily always a clear definition. And the meaning of doing something in an agile way sometimes means a set of practices or a set of measurements or a set of metrics. It can really vary. So when I say be agile, what we mean is more a idea or an orientation of working than a specific set of things, but you and your agency and your situation can work out what does that mean. Do you want to do Scrum, or do you want to do Kanban, or do you want to do other kind of practices that all fit into sometimes the agile category? When we say agile, though, in general, what we mean is that you're creating and iterating on working software instead of making giant comprehensive plans. The core work effort is in the software itself and the documentation of the software and the comments on the software, not in the planning document that you made. If you want to see how the system's working, you see that in the actual code itself. And you start by putting things in the code from the very beginning. Agile, when done properly, is always going to be more expensive than waterfall because you're expecting to change direction as you make a project. If we were omniscient, we could make giant waterfall plans that were exactly correct and then walk straight through them and we'd be done, and we would, that would be really fast and really efficient. But we know that 80% of the time in the government, or more, depending on how you want to measure it, the government has done that waterfall-like approach and then gotten to the end of the line, and then the result isn't useful to anyone because we didn't learn or iterate or change along the way. So when I say be agile, a lot of what I mean is make your executives expect to be agile. Make them expect that you're going to have to change direction. As you do this first pilot, you might have to do something different. Because when you change direction, you learn, and when you get to the end of the road, you will have something that is useful, even if you change direction a lot. Or you're going to find out, hey, maybe this isn't a good investment to make, and you'll fail a lot faster and cheaper than going all the way down the line. Part of this is also organizational culture, where it has to be safe for people to say, this isn't working. Because otherwise there's a tendency to say everything is great, everything is great, everything is great, and then you drop off the cliff.
So Agile is only more expensive when you compare it to the waterfall projects that succeed.
Exactly. That's actually a good way of saying that.
Yes. Okay. But 80% of waterfall projects don't succeed. So in the longer term return on investment, Agile wins. And it's easier sometimes to spot what isn't Agile than what is. Agile is often used as a club to bat people around the head with. If you're following the rituals and terms of Agile, but you feel like nothing has really changed, then you're not doing it. If you spend the first 2 sprints coming up with irrevocable requirements that have to be met, then you're definitely not doing Agile. You're just using the forms of Agile, but still practicing waterfall. People which we call Agile Fall, and we have a good blog post on that.
Yes.
But there are indicators here that you are doing this well when the team expects and appreciates, looks forward to the rituals because they know the retrospective is actually going to be used to help improve things. They want to hear what people are doing and help unblock them, and people are speaking up and feel safe to make contributions because they know their voice is going to be heard. The whole idea of psychological safety that Google has shown is a key determinant of what high-performing teams are.
It's a question of culture more than it's a question of exact practice. So you will know you're doing Agile well when your team has adopted a culture that expects the Agile practices, not when you're doing the practices by themselves. Otherwise, it's like that ends up being really painful. If you have a team or a culture that doesn't work with Agile and then you try to make that, you're going to end up in a sprint planning where only one person is talking, and that's not how a proper sprint planning can work.
Now, since we got started a little bit late with the audio problems, how do we keep moving forward and then pause for questions?
Yeah, we're going to get there at 5 more slides or so. Automatic code deployment. This should be a little bit of a quicker slide. What we mean by this is that you need to, when you commit code, have that code be deployed in the act of committing. Or to be more specific, when you deploy from your staging system or your trial system or whatever prototype into production, production goes live. There's not someone else having to click into something else to click make this possible, make this possible, make this possible. It is one flow. And you should start that process on day 1 by releasing code. You should be releasing code each day, every day, depending on what the system is. Sometimes it makes more sense to do it on a weekly basis in the beginning. But you want to have code deployment systems that are inherent to how your system works, not something you try to tack on at the end. It's part of the system that you run. That will also demonstrate and help you build confidence in your testing procedures to make sure that your code is good. When you deploy code automatically, then you're only going to feel safe really pressing that button when you know you have a lot of good tests. And good software has a lot of testing going on because the testing catches all the things that you don't think about when you're making a basic code change. Finally, that will, you and Puppet.
Yeah, and so you are going to have more test code than you actually have functional code. That's fine. That's expected. Your one-button release process doesn't actually have to be a physical or virtual button, but your release process should boil down to not many more bullet points on this slide. Get this command line tool, deploy this, check out this repository, and run these commands. If you don't actually have a button, but it kicks off the process.
Or a macro.
And gets it to deployment. Also, this gives you a great deal of vendor portability because then since you're not depending on 400-page screenshot run books, it means that when you are adding personnel or changing whole teams, you know that the intellectual property that actually says how the system works and all comes together is already there in code and, of course, in version control.
This is not necessarily something you can do with your Start Small, Start Poor project because a lot of times this is going to be a really big change for an agency, but it's an end state to get to so that as you do more projects, you can release code on day 1. But this is a big, scary thing, and I want to acknowledge that there are real blockers to this that have to be resolved. This is not a, come in and you can make all the changes to make this possible in a day. This is a end state to drive towards and something you can get to, if you just move up how often you release from every year to every 6 months, that's still an improvement. That's getting you closer to this. Start with security. We see an anti-pattern a lot of times where the people that are doing the coding and people doing the program and the people doing the security are kind of on different teams, and they have different priorities and different goals and different metrics, and that means they end up working in opposite ways. And that you end up spending energy and effort kind of working against people that are really all on the same team. Your agency is one team trying to work together to build out code. But that's partly because the code is sometimes developed without thinking about what security is or the workflows or all the elements of your system, not just the code itself. The code is sometimes an element but not the full element. You should have security in mind and have the folks from your security and compliance team in the room when you start to develop, when you start to iterate, when you start to practice. So that one of your failure points that I imagine you change direction as you do Agile, some of those points will be someone from security saying, hey, this really doesn't work, at least initially. We should really do it this way. And that's a good thing to learn instead of getting to the end of something, working out all the bugs and kinks, and then getting it kicked back over the wall and saying, well, that really won't work for all of these reasons. anytime you send something to security and you get back, you know, a 20-part resulting thing that says, like, you have this problem and this problem and this problem, that was 20 times that you could have found something individually going through a process where they were more involved with the team. Something that has worked well for us, we call it the ATO sprinting team. We had a team with the authorization personnel themselves and our team that worked together and built bridges and really became, you know, a team fully working to be both compliant but also providing results as fast as possible. And that made it a much more pleasant experience as well to get a lot of ATOs done. The final thing I want to add about security, and there's a whole other slide, there's a whole other presentation you can make about this, is post-mortem. When something goes wrong, especially in the world of security, there is a tendency, for a lot of good reasons that are way above all of our pay grades, to be really careful about what you say about it because of figuring out questions of blame and who did this and who did that. Your organization will not be able to be efficient as long as that is the case. Even if you may not be able to control this, but when you have a blameless post-mortem culture, when you run post-mortems for all the issues, big or small, and that becomes a normal standard process, people are much more likely to be able to figure out what are patterns that are causing these things to happen, learn and create, you know, some mental models of those things, and then you'll head off issues at the pass. So as you develop a post-mortem culture, people learn more, and eventually you have fewer security issues, and your time to recover is a lot earlier because you're running these post-mortems not just about what went wrong and what caused the problem, but also what was the process of recovery.
In organizations that do this, that shift left on security, as we say, so if you think of working from left to right, build in security as part of the test, so the same automated code deployment also runs static code analysis and perhaps dynamic busting of your code. Means to catch problems earlier where they're easier to catch and remediate. And so those teams spend 50% less time remediating security issues. So you have automation. You also not just have the code that stands for, but you have a way of making sure that patches and other updates are rolled out. And then for a great example of what's not a blameless postmortem, I think you may recall after the Equifax breach that the CEO testified that it could all be blamed on one employee. What he didn't say that one employee was him, because you should be building a culture that says all of this is about learning. We're here to learn and build, not to blame and play power games.
There was a vendor that they accidentally deleted a good chunk of their database, and they put their screen share and chat as they were fixing the issue live on YouTube. And everyone loved it for them. They got good press for that. When you're more transparent, I'm not saying we should do that necessarily. I'm not making that argument. But building more transparency and more comfort is good for everyone, because a system that allows one person to screw something up is a system that has been architected that works. Embrace an IaaS, PaaS, SaaS model, where infrastructure as a service, platform as a service, software as a service. We'll be quick for the sake of time because we have a lot more to get through. But this is kind of getting to what you said in the earlier part of the presentation. A system as built in a data center doesn't need to work the same way in the cloud.
You got the greater than symbol on direction.
Oh, I did. I'm saying things should be moving, building on top. Okay. Right, that's what I'm saying there. I think that's what I was actually thinking about. The benefit of doing things in this model is that you can reuse portions of authorization. If you set up infrastructure in a good way, you can reuse that infrastructure multiple times. If you set up a platform in a good way, like cloud.gov, you can use that platform multiple times, so that the only thing your program teams have to worry about is what's happening at the software level. If they don't have to think about what's happening below, it's like catching a cable car that takes you most of the way up the mountain, so that your final summiting, you can focus on what actually matters in the system, the workloads that people are actually following, not all the stuff beneath. Every time you answer the same question or do the same work of what's kind of below the iceberg, below the ocean, about what's taking all that time, you're not spending time thinking about the actual user service. We want to try to make that as efficient as possible by using infrastructure as a service and platform as a service. Got it. Cool. Agile procurement. Neither of us are acquisitions experts, so this is a set of ideas, but I think with questions, especially on this front, there's a great website that you can look at, and I'm happy to answer some of the things, but I don't want to represent myself as an expert on this issue. In general, when we talk about agile procurement or modular procurement, what we're saying is a different set of practices that enable you to get to these outcomes. Sometimes you are going to be locked into contracts that make some of the things we've already talked about really hard or impossible. So these things all work together, and sometimes you just have to, you can make, iterative improvements within the bounds of what a contract allows. But as your contracts do come up for renewal, as you have new procurements that you need to set up, here are some practices that we suggest. Instead of having a long list of detailed technical requirements, which you shouldn't have because you don't know them because you haven't planned out your system waterfall style, you want to have a challenge summary that says, here's the problem that we're trying to solve. You want to have lots and lots of smaller proposals that all work together so that if one part of your project falls through, everything else can still work. Your system in the cloud doesn't have to be like one system running on one place in a data center. You could have multiple pieces of your system all communicating, and that will then allow you in the future to upgrade piece by piece by piece instead of having it be one monolith where one failure brings down the whole thing. You want to plan to evaluate the things submitted to you as part of the buy in weeks instead of months because they should be smaller things to evaluate. You want to set up your contracts to reward not the doing of a lot of work, because it's very easy to do a lot of work that goes nowhere, but instead to reward actual delivery. And you want to set up things so that you have moments of early failure points, so if something isn't working, you learn, you've lost the money, and you move on instead of building yourself and going in a bad direction. You'll know this is working when you've broken up one of those large monolithic contracts into something small with different pieces. I know this is a tricky thing. This is something that we can help with and talk a lot more about. There are people presenting about this right now on panels in California. So ask us more questions, but this is the first step, and modular contracting at ACNS.gov tells you more. But I think the biggest thing for this audience especially is that we know that procurement can be limiting for us, and so there's a set of solutions here as well that apply to COs and CORs and the work that, the USDS contracting team and other folks are doing. The really big cool thing is once you get to the end of this way and you've done this procurement in this style, even if one of your systems completely falls over and has a big problem, the rest of your systems stay up, and that's wonderful.
So you are going to have to combine this with an enterprise architecture that supports modularity as well as the underlying level. So if everything's talking directly to a database, then you can't change out the database underneath it. So this does come back to technology saying, make sure you're using APIs that represent how all your applications are talking to the database, so the database can be changed without the other applications having to know, and other thoughts along those lines.
So we have finished half of the presentation. The next half is going to be all about how we've done these things and how they've worked so that you have data points you can cite when making these cases.
The conference is now in silent mode.
Peter was going to take us through cloud.gov as a case study. I may pop up with a few of the thoughts, and then I'll talk about Federalist. But Peter, take it away.
So this is a case study both in terms of we have tried to apply some of these strategies ourselves as we've moved forward our product, as well as being able to enable our customers to employ those. And when we talk about a culture of innovation, culture comes about because your tools can help support certain kinds of behavior, and then behavior and habits then inform the kind of culture that you have. And in the end, this means that your tools actually matter, and particularly for those of us who are involved in building customer-facing platforms or services that the public or other members of the government are using, your platform matters. And the platform, in the sense that it uses platform as a service, is where you're going to have a team that comes together that needs to build, test, and run a suite of technologies and administrative steps that include what's your stack, that includes perhaps a web server, app server, database, etc. How do you have multiple environments that are identical largely across local development, shared development, testing, all the way up to production? How do you manage the users that are going to be having certain roles in there, whether they are all-powerful or someone who's read-only? And then there's the work that's been typically delegated to an operations team, taking care of patching, shipping logs, making sure that the system is available, and scan for vulnerabilities. Traditional platforms that we've worked with often add friction to this process of agile delivery. And platform as a service can often be your best support for iterative work. And platform as a service is a pre-built environment for deploying applications. So we have your developers on your project team being able to focus on mission needs. And then the common technology resources within that stack, many of which I have on the other slide, are managed by an expert operations team. If you've probably seen something like this breakdown before of platform versus data center versus infrastructure as a service, in terms of who's responsible for the facility or the hardware or the platform. A lot of government cloud adoption is focusing very much on the infrastructure as a service layer, forgetting that there is an extraordinary amount of work that happens at the platform layer in terms of all these bullet points here, from operating systems, automated updates. So how do we reduce what you manage as common across government? Well, in 2016, there was no available platform as a service running open source framework that was authorized within FedRAMP. So at HTNF, we were seeing that a lot of the work that we were building in conjunction with agencies just couldn't ship because trying to do the full authorization for everything at the infrastructure as a service layer, in addition to the code we were writing, was just becoming insurmountable. So a team built cloud.gov, which is platform as a service, using the open source Cloud Foundry product, which is in turn built on top of AWS GovCloud. And we have had an obsessive focus on baking in federal security compliance so that as you adopt the platform, we make compliance as easy as we can.
Two other notes quickly about this. One is that we used to provide, HTNF sold AWS directly to agencies, or we made it possible to access infrastructure as a service. We stopped selling that because it didn't work, because there was too much other work that agencies had to do configuring the AWS that we were basically spending more time on calls with them, helping them use it, than we were actually making it available and being able to work on the core product. So we stopped providing infrastructure as a service. We now provide platform as a service. The other note about cloud.gov is we made it initially to support our own needs because our own team wanted to deploy a product. So we started small, not with the idea of building a full system. And then we realized, oh, wait a second, we've made something useful for us. Maybe other people can benefit from it. So we just stamped the cloud.gov label on top of the thing we already made, and that became the product that Peter's talking about. So how it works is that your team can bring custom software that you're writing, whether it's the Forest Service or the permitting system, or you can bring off-the-shelf software. And then we have delegated self-service tools that those teams can use to commonly configure needed services like databases, storage, and content delivery networks. And then that team also has the power to, as we mentioned earlier, deploy a prototyping environment from day one. Because it's all done as code against an API, it makes it very routine to take the deployment process and put it into some sort of continuous delivery system so that when code is checked in, it gets tested, released to a testing for a prototyping environment. A number of different agencies are using us now. I don't have all of our logos on the slide, but the Federal Election Commission is one of the ones we like to talk about because they have a very elastic demand because 3/4 of the time you don't think about the Federal Election Commission, ideally, except perhaps in the run-up to an election where you're wanting to see who's filing what, reporters are checking it out, the campaigns are filing, and so they had to have a lot of excess capacity to support some kind of peak need. Once per quarter.
And then there's a filing once per quarter. So by going to cloud.gov on top of Amazon Web Services, they were able to save $1.2 million in savings annually. But more exciting to me was being able to sit down with those teams in some of the scaled agile framework training and see how the platform was able to support them truly adopt agile. Because instead of having to react, break fixes, and rework, they're able to say, this is where we want to be in 3 months. And some of the work we're going to do at 2-week increments and release every 2 weeks. Because we have the self-service platform that includes the ability to codify all the steps in the release process, they're able to test continually. And as, I forgot to put his name in, Wei Lu has authorized this quote. Wei Lu, Deputy CIO at FEC, says, when I talked to a reporter last night about this one, I told him I'm sleeping it well at night. Even though it's a big project, it's been tested for a year. Because for a year, they're able to have an introduction, actually connecting to their log backend database, continuing to build out more functionality in their new site until they're able to switch over. We chose Cloud Foundry because it was the platform as a service available to us as an open source model and is proved to be a really great choice. It has a huge community. As of April, we're now designated a certified provider, meaning with the same class of providers as IBM and SUSE and Centurion Asphalt in terms of API compatibility and keeping up with current releases. This means that potentially you could run Cloud Foundry internally and take the code that we were running on cloud.gov and move it to your own installation or some other vendor. And then, of course, we have this huge ecosystem that's contributing more and more features all the time at the platform layer and the consumer layer. This reduces vendor lock-in at two levels. One is actual application portability, and the other is that vendors who are building Cloud Foundry, they can say, oh, I can bring this application that we've already built to run in Cloud Foundry, run it on cloud.gov, and you don't have to wait 2 years to provision the server and the database and the networking to run that, even with your own infrastructure as a service, if you don't have good automation at your current agency. We have FedRAMP authorization, so we're just got our second year of that. We're in the same group as 100 CSPs that FedRAMP has now authorized. We can run workloads up to moderate. And what is interesting here is not just the fact that have this can run workloads up to moderate, but we take a lot of steps to think about how can we reduce risk and enhance security. So when we do a lot of security by convention for our customers by making it simple to do plain language configuration of their defining the system that they're building. If you have something like an S3 storage bucket, if you go to configure that in AWS, you see that there are probably 400 different options how you can configure a bucket. Right now we have two, it's either a public bucket or a private bucket. We're going to add a few options for how to roll things over to Glacier. But by keeping the options to the 80 to 90% use case, we can make it very clear what it is that people are doing to actually use it. And again, we are always taking care of having the right defaults in place, configure a database, has encryption at rest, there's system requirements, as well as encrypted connections. And since it's self-service, if you get a prototyping account for your agency, anyone in the agency can use cloud.gov. There's no need for a shadow IT, or sometimes called a credit card cloud, where someone puts some cloud on an SD card, it just won't get work done. We talked earlier about taking a cable car up the mountain in terms of IaaS versus PaaS versus SaaS. If you're launching a application that's going to be rated dismal moderate impact, you have 325 security controls that you need to attend to. For a simple application running on top of cloud.gov, 269 of those are already inheritable from our security plan. 41 of them are shared, 15 will be your responsibility in terms of are you doing static security code analysis, have you vetted who your contractor is. And this is much more than you would get from any infrastructure as a service provider. Typically, you can, at best, inherit 85 to 100 infrastructure as a service. Ourselves, we're built on top of AWS currently. We inherit 54 of those. We also get all the benefits of being on AWS. And eventually, if we're able to run as well in Azure or Google Cloud Platform, you would have those infrastructures underlying what we're doing in cloud.gov.
Peter, interrupt. They're saying you could speak closer to the mic.
Oh, because I keep stepping forward. As I mentioned, we have the joint authorization moderate ATO. We're built on top of AWS GovCloud, and Will and I and others go through the GSA background checks in terms of position of public trust. And we are, workloads are multi-tenant, but everything runs as a container, so you have that level of isolation from the different workloads running within cloud.gov. You can configure something like a database. You would configure your own database that's not shared. And we're able to, in the background, continually manage patching and operations. Mentioned before, we ourselves have everything as infrastructure as code, including configuration files. All of our secrets are managed in secrets management systems, so we know what changes when in terms of database credentials. Version control, we test all the changes in how we run the platform through multiple parallel environments before we actually release that to the platform that is running our customer application. Because we have this automation, if there's a patch or a library or an operating system vulnerability, we're able to do that within hours of release without any downtime. Let me show how that works. If you run an application on cloud.gov, let's say it's just called My App, and it's available at the URL my.app.cloud.gov. When you request that URL, it'll go to our cloud.gov router and get routed to the worker cell where that application is running. Ideally, you'd have multiple copies of that application running across multiple cells, so if one of them goes down, there's no downtime. Now, suppose we find, and this happened in January, that the worker cell is indeed affected by the meltdown bug, and we need to remediate that throughout the entire platform. We bring up another working cell, which is an entirely new VM that's been built and hardened to run within cloud.gov. Instantiate new copies of your application and everyone else's. Tear down the old route, and the new route is available there on the fully patched system, and then we can just tear down the old cell. We do this at least every 2 weeks, and more often if vulnerabilities are released, patches are released more often than that. And as we mentioned before, it's key to have continuous release automated deployments. We practice that ourselves with what has now become a rather daunting number of pipelines for continuous delivery, but we make sure that all of the inputs to the system for building it are scanned, vetted across multiple environments, and tested as they're released. So that is how that goes at a whirlwind tour. We have, if you go to cloud.gov, we have some of our customer stories there. I should mention, this is not here on the slides, that we are applicable for applications that are roughly written within the last decade, things that done Java, Ruby, Python, .NET Core, and support most common databases. So that, I think, sets the stage for Will, who, running Federalist, is a software as a service offering that runs on top of cloud.gov.
Yeah. I'll just make two other notes about cloud.gov. It's not the thing that you have to use. We made it to be a reference for you to do something on your own. However, we think it's really handy, and you might be able to start with using cloud.gov at an agency, and then you don't have to do all this work on the platform to show that it works and show that it's safe and show that it's stable. All this tooling that we have is also, it's all open source, it's all available, and to be really specific, our use of our particular infrastructure provider is not, we're not saying they're the best infrastructure provider. It's just cheapest to do one at first. But ideally, we'd love to put this, and this code can be deployed on multiple infrastructures because Cloud Foundry is infrastructure agnostic, how you can deploy it. Yeah, cool. Excellent. So let me talk now about a case study for Federalist, and we should have plenty of time at the end for about 20 minutes on a question. And I'm going to also talk specifically about, at the end of my little blurb here, about how Federalist helps you implement some of the ideas we talked about in part 2. So look for how you can draw those things in comparison. First, though, I want to talk about the problem that Federalist came from, and that is running even a basic website in the government to inform the public about anything that the public, any kind of public matter, can be really, really expensive. It can be really hard to get the hosting right for that. Peter already talked about this, but the idea of traffic surges. Sometimes you make an announcement every year, and that's when you have a lot of traffic, and otherwise you have no traffic. It is for that reason that there are basic static websites in the government that have cost dollars per user per month to host. Dollars per user per month is not okay, and yet that's also kind of our normal state, at least in some parts of the government, because of this spiky nature of buys. You're always wanting to make sure you have the ability to accommodate this many concurrent users, even though 95% of the time you have that many users. Getting an authority to operate, we've been talking about that all day. That's really hard. Even if you have a static site that just says hello world and H1 close tag, that costs a lot of money to ATO because of all the stuff that lives under it. It's not the actual content of the web page. It's the system that deploys that content, how it's hosted, how it's monitored, how it's tracked, how it's paid for. That's what the money ends up being for. And then maintaining that compliance and mitigating new security issues, when you add all those costs together, I have been told by other agencies that it costs $66,000, $70,000, $82,000, or $95,000 to deploy a single page of HTML new. It should not cost that much, but that's the natural result of all this other work if you're having to do all that infrastructure and platform stuff every time. If you're having to hike up the entire mountain, even if your final step is a single page of HTML, you're still having to do all that work to climb the mountain, none of which actually helps you deliver the value to the people that you're actually helping. The ability to update content can also be really hard, where people have to send an update to a core, who then sends it to a lead contractor, who then sends it to the subcontractor, who then has to put in a ticket, and then the update is made, and it's been 2 weeks, and then it's already too late. Or if there's a typo, you have to go back to the whole process again. So this is the problem that we have, even when we're deploying the most simple but also more complex sites that are all about getting information out to the public, which is a lot of what a lot of government sites do. They're just explaining things when people have a given need or concern. And you can see the highest traffic government websites at analytics.usa.gov. So that means we end up in a world where it's normal to take 6 months to launch a new site, and it's difficult to update that timeline. A lot of agencies solve this publishing issue using a CMS, content management system, and examples of that could be Drupal or WordPress, or there's a lot of other really interesting legacy tooling that's across the whole federal government for this exact issue. These can be totally great and workable solutions. I am not telling you that you need to not use a CMS. A CMS is a great example of software as a service, since most CMSs are built on top of a platform. However, a CMS has a lot of possible exposure points for attack. If you want to add new functionality and features, everyone else is subject to those. You have a lot of people logging in. There's a lot of possible points of issue. And for a lot of agencies and teams, you don't have the resources to run a full team to support that CMS. Your agency or your office or your team might be more like a little small business, like a mom and pop, garage, for which the web server is kind of sitting over in the corner. And, the government, I've heard before that agencies or teams will pick the youngest lawyer and say, like, you're the tech person, you'll maintain the site, because they otherwise don't have anyone on teams that don't have this as a resource. So these small businesses don't have the ability to support a full WordPress or Drupal install, and they don't have the ability to get support otherwise. So we made Federalist to support the government equivalent of that small business, as well as anyone else that wants to be able to easily prototype and launch web pages. These web pages can be really complex and really big and have lots and lots of pages on the site, but they could be really simple. But Federalist is in a big part for this talk about that first step into cloud that you might want to take. It serves federal employees by handling the back end and compliance work to launch web content so that people can focus on their own front end. You can spend your effort designing your site, making sure it works well, making sure it serves your users, not on the ETO work that's required to get it launched. And we do that by leveraging static web hosting. When I say static web hosting, what I mean is that it's a system where the site content is deployed onto like a file server, and I think a lot of you already know what this is. In our case, Amazon S3, and then that content served out of there. I'll get into those details on a later slide. So if you're an individual program or an office or a campaign or a new effort to hire someone or a micro agency and you need to launch or manage web content or data, or you're a really big team and you want to use a cool feature or a cool service that we've made that helps you show out the benefits of all these processes we're talking about, Federalist is here for you. Here's some examples: the IT modernization report that came out in the fall, the binding operational directives from DHS. I think a lot of us dealt with those, that saying you had to add DMARC to your DNS to make sure that the email was set up well. Federalist hosts the website that explains what those things are. The college scorecard that Peter showed is cloud.gov, is an example of you using an API plus a static website together. And those tend to work really well together to reduce attack surface. I'll talk more about that in a later slide. So what are static sites? That's instead of, you could think of a web server as an always on, always thinking server that when someone asks for a website, it's pulling together the content of that page and then it's sending you complete HTML. With Federalist or with static sites, we're doing that process of pre-building one time so that it's very cheap and easy to host the actual sites themselves. So the downside of that is that, let's say that you have someone, you're running a blog and someone wants to submit a comment to the blog. Well, usually with a CMS, if you type in that comment, the web server gets that, it updates its database, and then the next time someone visits that blog post, boom, there's a comment. That's not possible with a static site, but most government websites aren't blogs with commenting on them, and you can use an external service or an API to provide that same kind of commenting feature. You save a lot of money when you have a deploy system that is working very well, and then you'll service can buy it. And an infrastructure as a service for this, specifically the file hosting in S3 is I think less than $1,000 a year for all the websites that PTS hosts. We're spending a lot more time and money on the systems that we're running that are doing live calls and doing, providing the results of those APIs. But the websites themselves that are all static, very, very cheap and efficient to host. So we do that by building on 2 compliant platforms. Peter already talked about AWS, and we're using S3 as that cost-efficient hosting. And then we use AWS CloudFront, which provides a CDN service. That means we're not always tapping our own S3 buckets. And then cloud.gov is a platform as a service on top of AWS, and it's brokering all the AWS components. So I don't actually use raw S3. I use S3 as configured by cloud.gov. I don't actually use raw CloudFront. I use CloudFront as configured by cloud.gov. And then cloud.gov has gone through a whole FedRAMP process certifying these various bits and pieces, which is a whole long story in and of itself that has allowed us to do much less compliance work to give Federalist itself its own ATO. This architecture means that you can minimize your attack surface. If you're using someone else's infrastructure and someone else's platform, you can just focus your own security, not only your own user design, on what your users actually see and use and mess with, not on all the stuff below. So if we have a DDoS issue that comes up, I know that cloud.gov is going to be able to work on that, or whatever my platform as a service provider is, because I could deploy Federalist on some other platform if I wanted to. The tooling itself means that you're focused on what you're actually doing, not the stuff happening below, which is really important for trusting Federalist because my small team is not having to manage a giant amount of that mountain by itself. We're focused on the service that we provide, which means we can use more of that service with a smaller team. Same goes for cloud.gov, which is providing a really big service with not a huge team. So what are these transformative practices that we talked about in the beginning part of today, and how does Federalist help you apply them? The first one I would say is live prototyping. Federalist uses GitHub to host the content of the sites that it hosts. And every time that someone commits to GitHub, it pushes a new version of that page, and it does so immediately. It's a push-button deployment of your static content by committing code. That's just how Federalist works. Because this is static content, there's not really any, you're already deploying your code publicly, so the content itself is not going to be anything bonus or extra in terms of security risk, and it means that you can try out multiple versions of your site. If you have a main version of your site that's in your master branch in your code repository, and you have 4 different developers working on 4 different features, each of them can build out a full copy of that site using Federalist, the service, not locally on their machine, to test out the change that they're doing. That means I'm not just having one staging system that mimics production, I have infinite staging systems that mimic production that Federalist makes possible. The other really cool thing about that is that it lowers your QA costs, because when you're using these live prototyping, then your developers or your content writers, if you're managing content on a website, can check and make sure their content renders appropriately, instead of someone having to be the big, or you if you're the responsible party, having to check everything individually. That gets painful and annoying and takes a long time. You're distributing out the work and distributing the Q&A by using this live prototyping. We also talked about CI/CD. That's how Federalist works. It'll just continuously deploy all the new code changes that you make, and if there's an issue in deploying your code, it will not it will not just break your entire site. Instead, it'll say, hey, this deploy failed, and your old site will stay live in S3. So this means that I'm also breaking up my system into two halves. The process of deploying the live sites and the process of hosting the live sites are different. So even if my build system completely goes down, all the sites stay up because I've disconnected my build process from my hosting process. Federalist is also entirely open source, enabling people to leverage each other's code. So for example, those two examples I gave you earlier in the talk about the IT modernization report and the DHS binding operational directives, those two URLs are going to look really similar. You can go to each of them right now, cyber.dhs.gov and itmodernization.cio.gov, because all we really care about is the content. The actual look and feel of it, this is presenting kind of dry stuff, to be honest. Even though I'm really excited about IT modernization, I know it's not the most exciting thing for a lot of people. So we didn't spend a lot of time, and I used the royal we, I did not design or develop these sites. The folks making them were able to borrow from each other so they could focus more on the content and less on the look and feel. Every single Federalist site that we host, all 120 of them, you can look at and steal all the code and make your own version of them. And people have done that over and over again to save a lot of time and money, just as when you're doing deployments to cloud, if you have all your stuff available in a code repository, it's really easy to borrow someone else's work instead of having to climb up the entire mountain yourself again and again. That also means that you can take a cool feature from an outside site that you like that's deployed using one of these static hosting systems and bring it inside. You have to vet all the code yourself, of course. Federalist, one of the misconceptions we hear about open source sometimes, people think that open source means anyone from the outside world can commit code into my system that then goes live. That's not good deployment of open source. You still need someone inside the government vetting and approving any new code that someone might want to introduce and running a lot of tests on it. But it does mean that we can bring in services and features from the outside pretty easily. Next up, cloud hosting. Federalist is for some agencies the first time that they've ever done something in the cloud. One example of that is DHS hadn't used AWS for production until it hosted cyber.dhs.gov. But for a lot of other partners, they've never touched anything in the cloud anywhere, anyhow, because there's so much work that's involved in doing that first step. So when I said start small and start core, you could start, and it wouldn't be a full representation of all your agency systems, but you could do one thing by trying out using Federalist and all the technologies that are involved in Federalist to put out the public-facing website for your agency. You know, the one that says, here's our commissioner, here's our lead staff, here's our biannual reports, or whatever else. That's the kind of thing that Federalist excels at, that lets you do as a first step, and then you can see, how does the system work? And you can get your processes ready for when you start doing this for your other systems that you run as an agency. You can start experimenting with using static hosting plus an API for a much smaller attack surface, and Federalist makes it possible to do that. Because all of the stuff is maintained in version control, it's really easy to see and approve new changes. So instead of people having to look at a new edit to the website via an emailed around Word document that gets, expensive, so it's really painful if you're one person and you have 3 people all giving you comments and all the comments, like they're editing the same thing at the same time, that's annoying. Using version control means that different people can edit different versions of the site, and then you can combine them using the best practices of GitHub. And it's really easy to audit something to figure out if something went wrong, what happened. So version control means that the sites are there, their history is public, and it's pretty easy to manage. And you can, if you need to, add that code repository in a private world. But for the most part, all of our federal sites are public because we want to share things with other government agencies. And then finally, Federalist, on this slide, Federalist is demonstrating the power of the IaaS as SaaS model because most of our ATO controls are being handled by cloud.gov. We're just focused on the stuff that we're doing, and we've gotten really good at it. So we can provide a lot of neat features on top of what cloud.gov makes possible. Like, for example, this infinite prototyping thing, which I think is pretty cool. There are a lot of other private sector companies that do the same kind of work, and you can benefit from them, especially if you're running your own personal blog. Some of them drew inspiration from Federalist and have told us that, or were started after that, or thrown a lot of seed capital, but they don't have the same FedRAMP status because, for the most part, if you're a static hosting provider charging, $10 a month for something, it would take a lot of federal websites for you to break even on doing FedRAMP. So that's why Federalist is here to provide the same kind of benefit, but for the federal government inside using the same kind of technology. The final thing I want to make about Federalist is how it helps you work better with industry. Just in the same way that you in cloud procurement in a good way, you're going to end up in a better and more healthy relationship with industry. So one is that you are suddenly not restricted to only those vendors to the government that have worked in your legacy systems before. Instead, those web developers can use their favorite tooling, their favorite design work, their favorite front end, because we've handled the back end so well. We're giving people a lot of freedom in terms of the front end of the website, subject to your agency's rules and restrictions, but by providing the full solution on the back end. And so Federalist, kind of by decoupling those things, enables a lot more fun, I think, for vendors when they're not stuck within a limited set of options that were made available under a CMS. That means vendors can be excellent at what they're supposed to do, which is designing quality sites, and you don't have to have a vendor that's developed its own expertise or its own access to FedRAMP hosting. That can be really hard for a vendor that, especially one of the smaller ones, if you want to have more contracts going to more small businesses or 8A or 8 stars or whatever, you can do that by making Federalist the hosting and then getting the web design from a vendor. We've had a lot of agencies do that. They will set up a site with us. They will hand that off to a vendor. And we have to have some really good relationships with vendors that have been running sites for years now, where we're the hosting and they provide the service, and it works out. It's a pretty awesome combination. That also means you then don't have to pay the surcharge of each vendor having to maintain its own FedRAMP expertise or its own access to infrastructure because they're getting that separately. It also modularizes your buys so that you're not buying your entire website from one vendor such that if you ever need to change, all your website and all its content and all of its history is lost to you. There are a lot of government agencies right now that don't control their own data because it was part of a contract from, in some instances, like 1986, right? We've seen that situation before. Like a contract just is rolled over and over and over again. That can be pretty tough. And then finally on this point, it lets you do smaller contracts for more individual sites. Instead of having one contract for your entire enterprise, you can do one for one site and start with that. I think that is the end of my presentation. So I have some content information here, and otherwise we're ready for questions. Thank you.